am Roshanida. Thank you for the nice introduction by our chairperson. RSM is actually just one of the tools. We have so many tools for optimization process, and RSM is just one of the tools. So DOE is the main focus here, or the main subject here. Yeah. The meaning from both of these definitions is almost the same. If you want to identify the factors, the significant factors that will affect your process or your product, or you want to make optimization or improvement for your product or for your process, then you have to do the DOE. Why RSM? So why RSM? Or why DOE? Even though you can see here, there are 8 purposes or 8 objectives, but overall the ultimate goal or the ultimate objective or the ultimate purpose for this RSM is the same. So the first variables that you should know is factor. I think everyone knows what is factor. So factor is the variable that you have been chosen in the beginning of your study, the factors that you want to manipulate, we can say is you want to manipulate in order to see the output. And the second variable is response. So we have the input variable just now, which is factors or independent variables. So we have response or dependent variable. How about the other variables? As I mentioned just now, that maybe from your reading, from your literature review, so you have 10 factors. You think that these 10 factors really affect your process, but I only want to choose 3 factors to study. So you have to be very careful. You have to justify why only 3. How about the other 7? What are you going to do with these 7? Because in order to conduct any experiment, you still need to put the values of these 7 factors. For example, to conduct any experimental design experiments, you have to know these principles. Okay, you have to know these principles. For me, it's a must. Yeah. The first thing is randomization. And the second principle is replication. You have 2-level factorial design, 2 power of 3, you have 8 runs. So you have to do, if you replicate once, and you have to do, or you have to conduct 16 runs. The whole experiment. You replicate the whole experiment from 8, you will have 16 runs. The next principle is blocking. So blocking, if you use design expert software, that is one thing you need to add, whether you want to use blocking or not. You can calculate by yourself. If you have 5 factors for screening process, or you want to do straight away optimization process, because all those 5 factors are extremely significant, you don't have to check whether it is significant or not. So you straight away you decide, you have decided, okay, I want to run optimization. I don't want to run screening, or I want to run screening just from the literature review. Of course, you can do screening process from literature review, yeah? But it also can be reflected in the equation, in the mathematical equation. So if you have the interaction effects in the equation, so just now we only talking about the single effect. We want to see only what is happening to this yield, to the Y, if we have only single effect, x1 time x2 temperature. How about the interaction effect? That's why we have X1 and X2 here, B12, the constant for the interaction effect. So you can read, you can see whether the term is significant or not from the ANOVA table, from the equation that, okay, you have the problem during the selection of the range. We can know that straight away from the statistical analysis actually. So if you want to if you want to conduct optimization process after you have done your screening process, yeah, by using two-level factorial design, or we have other design rather than two-level factorial design. For example, Plackett-Berman. If you have heard that before, Plackett-Berman, that one also involve linear equation. One of the equation from the screening process. You can see here, okay, the words here, the sentence here, the relationship between all factors toward the activity. Yeah, this is the activity, the yield, the Y. So the activity shown by this equation. So the fitness of the model, this is R squared. Later on, I'm going to show you. And explain, the response can be explained. The response is the yield, okay? The response can be explained by the linear model. So as you can see here, there is no quadratic effects, no cubic effect, no higher order model here. It's only linear equation. So normally in the software, the confidence level is 95%. Yeah, 95%. But if you have a very sensitive data, which is or very sensitive response, even 0.01 or 0.1, even 0.001, so in our area, in my area, for those who involve with DNA, the molecular level, or maybe in other area also you have that kind of study. So even a small, very small numbers of differences between the response affect a lot to the process. Then another, the first one is the p-value less than 0.05. And then the second term, you can check whether your model is valid or not by using the R squared, the confidence coefficient of determination, R squared. If you plot any graph also, you have to get the values of R squared. So we want to have higher R squared process. And when you want to start your screening process, another question will come up. What is the best method for my screening process? Am I going to use OFAC, one factor at a time, or the conventional method? Or am I going to use factorial design, two-level factorial design? How about the Plackett-Berman design? How about the Taguchi method? So this design that I put it here, all you can choose for your screening process. And why we call it a screening process and why this design excluded the OFAC? The other design, you can get linear regression analysis. You can get linear equation because it is for screening process. Okay, and from my experience, I always advise my student, when you have categorical factors, categorical factors such as type of microbe. You have 3 types of fungus, for example. So are you going to do factorial design? No, definitely no. I will ask them to do OFAC for categorical factor. Because if you have categorical factor, you combine with numerical factor, you put in the factorial design, you will have, I can say that you have double, triple numbers of runs. It will be very long list of runs you need to conduct. So if you have categorical factor, my advice is go for OFAC. For example, in our study, we have to study when we do medium optimization for the microorganism, we have to determine the type of carbon source. For example, we have so many carbon source to choose: glucose, sucrose, fructose, for example, starch. So we have 4 types of carbon sources. So which one is the best? We want to do optimization. So I always advise them to just go for OFAC first. Decide it first. Yeah. Then you can do the numerical screening or numerical optimization later when you finish your categorical factor. Unless it is you have decided, you have arranged everything properly, you have organized properly, then you can include at least one or two categorical factors in your RSM or in your factorial design. Can, but you have to organize it properly. And then after you finish your screening process, the objective of the screening process is more on the to get or to determine the significant or insignificant factors. When you get the significant factors, for example, from the 8 runs, from the 8 factors, only 4 is significant, and these 4 will be used for the next level, which is optimization process. So I'm sorry, because this 2 hours is definitely not enough to cover everything. So many things that actually I want to share with you, but I couldn't fit it into this very limited time. So the next process is optimization. Actually, optimization process is similar to the 2-level factorial design. Only the equation will be polynomial equation, and also the type of design, of course, definitely will be different from the previous one. So you can use CCD, Central Composite Design. It's a famous design, I think. CCD. Actually, CCD is part of factorial design. Central Composite Design is factorial design, but with because it's not only 2 factors, two level. In CCD, we have five levels. You have to add the, what we call it, the positive alpha and the negative alpha, what we call it in the normal term. I can't recall just now. But instead of we have -1 and +1, low and high, you have also to put the values which is negative alpha and positive alpha, which is beyond that low and high value that you have decided in the first place. So instead of 2 level plus the center point 3 level, so you will have another 2 levels, 2 points, which is totally you have 5 points. And definitely when you have these 5 points, you can get the good curvature if you have the curvature, the optimum point in your response surface later. So that's why CCD is part of optimization process, or the higher order model equation will be produced by using CCD. It's part of factorial design. The concept is similar to factorial design because it is 2-level factorial design. And also next is Box-Bacon. Box-Bacon also one of the familiar design that have been chosen in many optimization process. It has 3 levels. If in 2-level factorial design we have -1 and +1, but in Box-Bacon we have to put exactly the values of 0, the center point. In 2-level factorial design we have the choice whether we want to just to do the center point as part of the experiment to see the error, pure error. But in Box-Bacon, the 0, the center point, is a must. It's part of the run. It's part of the run. The 0, -1, and +1. So it's actually 3 level. Instead of 2 level, it's actually 3 levels. And the 3-level factorial design almost similar to Box-Bacon, which is we have 3 levels. So maybe in the latest software, the version 13, I'm not sure how it looks like. Maybe there are some other designs has been included and some has been excluded from the software. I'm not sure because I'm still fixed with the very old version 20 years ago. Okay, I think it's already 11. I think I'm going to stop there. I also share some of this is just to show you what is response surface. Actually, the 3D surface you can produce from the from the software. And this is actually what we want. When we want to get the optimum point, so we want to have this kind of very nice curvature in our at the end of our analysis. Okay, so how to get this? There is a tips. If you conduct a very good screening process, especially if you do OFAT. I can see this from my experience. If you do OFAT, because you have each of the factors, you have the graph. Okay, you have the graph. So when you do OFAT, you have a very clear picture the range for your optimization study. For example, for the temperature, for the screening process, you have a temperature 10 to 100, for example, 10, 20, 30, up to 100. And from the screening, you can see that 50, 60, 70, 60 is the optimum. 60 is the highest yield. You obtain highest yield at 60 degrees Celsius, and for the optimization, you choose 50 to 70 as your range. That is the purpose of screening. Actually, the screening is to get the proper range for your optimization study. So for example, in this study, 60 is the highest, but we don't consider the interaction. We only check for the single factor because it is OFAT. So for the optimization study, for example, you want to use CCD, you put the temperature as one of the factor, and the range you put 50, 70. You put two level, 50 and 70, and you run the experiment plus the other factors. For example, other factors also you do the same thing. Okay. And at the end, if all the values from the screening process is the best range, which at the end will contribute to the optimum point, then only you can get a very nice curvature, very nice maximum response. This kind of curve, it's not very nice. The one which is very nice, you can get a very nice contour in the center. So that's why screening, the determination of range is extremely important. If not, you will get this saddle point. This is the optimum point at the end of this. But why at the end we'll get this saddle point? Because of the range. If I'm the one who already familiar with this area for almost 20 years, and I see saddle point, straight away I can tell you that, okay, this is because of the range. Yeah, because of range, you will get saddle point. Sometimes for me, I don't want to blame anything. I don't want to blame the student because maybe the screening process is not right, for example. It's not because of that. If the student really understand what is happening towards her process or his process is okay, maybe the student already did everything. The temperature, for example, the highest temperature for the study is 100. You cannot go more than 100 because of the limitation of the equipment, for example, because of the limitation of the cost. You cannot go for 100. But the process you got is 100. The 100 is the maximum. And the student put the optimization point for the range 50 to 100. Definitely you will get saddle point because the highest from the screening definitely shows the optimum is at 100. But why you put 50 to 100? Maybe in the first place, you can exclude that factor and fix the value at 100 as the background factors. Or if you think that the factor would be beneficial to see the interaction effects. You want to see the interaction effect because it's even if it is at 100, but it's still okay, it's still good at maybe 80, and it will be produce high value when it will be interacted with the other factors. For example, you know what is happening, then you put that. Definitely, you won't get that optimum point contour plot.